Good afternoon, ladies and gentlemen. So today we're going to continue our work with quadrilaterals or polygons. Same thing. We're going to be able to classify them on the coordinate plane. So we're going to be given a set of points, and because we're dealing with quadrilaterals, we're going to get 4 points because we need 4 vertices to get a quadrilateral. So to be able to classify them, we're going to need slope and we're going to need length. So one of the things that I want you all to make a note of is that length is distance. So we're going to be using our distance formula once again. And we're going to be revisiting a concept from algebra called slope. So we're going to have a little bit of work to do here. So let's go ahead and get started. All right, we're going to go ahead and start. First, we're going to go ahead and sketch this guy because we want to get an idea of what this actually looks like. So just a real quick sketch. It doesn't have to be all perfect and pretty. Again, it's a sketch. I know that this is X and then this is Y. So just real quick, again, a sketch. So I know -1, +4, -1, +4 is somewhere around here. 2, 5 is going to be somewhere around up here. It has to be higher than the 4. So we're going to call this E. And again, this is a sketch, so it doesn't have to be exact. A is at 3, 2, so 3, 2. And then R is at 0, 1, right about there. It has to sit lower than that one, so there's R. All right, so it looks something like this. This gives us an order of which way we're going to be going. So we're going to go ahead and start investigating our slopes. We're going to go ahead and start with slopes once again. Okay, so we're going to start with slopes, and we're going to go ahead and start with this guy right here, BE. We're going to BE, so slopes. Slope is M. And if you remember our slope formula, and I'm going to write this up here so that way I don't eat up room for work. M is equal to y2 minus y1 over x2 minus x1. So we're going to have to remember that that's our formula for slope. Now I'm going to zoom in a little bit. All right, so we're going to go ahead and start with our slopes for BE. So we're going to go ahead and look at our points for BE, which are right here. And don't forget, we need to label them. X1, Y1, X2, Y2. So we're going to go ahead and do that right here. X1, Y1, X2, Y2. And we're going to go ahead and set up our ratio right here, or our rise over run. So we need Y2 and Y1. Y2 is 5 minus Y1 is 4. X2 is 2 minus X1 is -1. And if anything, one thing we do need to recall on a regular basis is that whenever we have two negatives, we're going to actually add. So these two negatives become addition. So we're going to go ahead and look into 5 minus 4 is 1. And then 2 plus 1 is 3. So that slope is 1/3. We're going to go ahead and do our next slope. And our next slope is going to be for what looks to be parallel. We're going to try to keep these together, RA. So we're going to do RA next. So we're going to go ahead and do RA. So M, and I want to start labeling these over here. That way I can keep track. This is RA. And then this other one was BE. There. So we have BE, RA. So let's go ahead and do our slope for RA. So same thing. We got to label our points. x1, y1, x2, y2. Okay, so we're going to need y2, which is 1, minus y1 is 2. y2 minus y1, so 1 minus 2. So 1 minus 2 over, now we need our x's, so 0 minus 3. 0 minus 3. So 1 minus 2 is negative 1, and then 0 minus 3 is negative 3. A negative over a negative makes everything positive. So right now our slopes match, and that's cool. But we're not done yet, because we have two other sides to this parallelogram. Or I should say quadrilateral, because I don't know if they're parallel yet. I don't know if everything's parallel, so I cannot call it a parallelogram. Right now all I know is it's 4 sides, so it's a quadrilateral. So the next part we're going to do is BR. So BR is our next slope. And once again, B and R are already labeled. Look, it works out, it works out. So y2 is 1 minus 4. So 1 minus 4 over x2 and x1 is 0 and negative 1. 0 minus negative 1. Oh, looky, looky right there. Once again, the two negatives come about. Those two negatives right there. All right, so 1 minus 4 is negative 3. And then 0 plus 1 is 1. Well, I can divide this guy out. So negative 3 divided by 1 is negative 3. Okay. That's another one down. Last one, last one. The one that looks like it's parallel is EA. So I'm going to do EA now. So EA slope. Y2 is 5 minus y1 is 2 over x2 is 2 minus x1 is 3. All right, so 5 minus 2 is 3. And then 2 minus 3 is negative 1. Well, I can still divide this. So 3 divided by 1 is 3. But then I have a positive divided by a negative is negative. And over here, it was a negative divided by a positive is negative. So all our slopes seem to match. Everything seems to be parallel. So these two, so BE is parallel to RA. And right here, BR is parallel to EA. One thing I'm going to notice is that 1/3 and negative 3 are opposite reciprocals. So if you remember, this is positive. So the opposite is negative 1/3. And then the reciprocal is the flip. So it becomes negative 3/1, which is negative 3. So these are opposite reciprocals. And opposite reciprocals means parallel. I'm not parallel, perpendicular. Geez Louise, I almost misguided you there. So again, opposite reciprocals means perpendicular. So I know these guys form right angles because they're opposite reciprocal slopes. So I can already put my right angles here. Right angle, right angle, right angle, right angle. Again, this is just a sketch. I'm not going to be pretty about it. All I know is that they're perpendicular. I can already mark up my sketch that this is parallel, and then these guys are parallel. So there, I've marked up my sketch. I'll worry about making it pretty another time. Now we're going to do distance. All right, so for distances, we're going to need this formula again. And we've seen it before. So we're going to go ahead and do the distance for BE first. Luckily, we already labeled our points. Ta-da! We already did that work, so no problem. So we're going to go ahead and do first x2 minus x1. So x2 is 2 minus x1 is negative 1 squared plus y2 is 5 minus y1 is 4 squared. So we're going to go ahead and do that math and check it. Don't forget you have minus and negative, which turns into a plus. After everything, you should have gotten the square root of 10. So now we're going to go ahead and do another distance, and this time we're going to go ahead and do AR. Because AR or RA had the same slope, we're going to go ahead and focus on that guy. So that's going to be next. So D equals square root. Go ahead and set it up, and we're going to check our answer in a bit. Boom! RA is the same distance or the same length. So now we're going to go ahead and repeat our process for BR and EA. Go ahead and do that, and then we'll be back to check it. And look at that. We're back to find everything is the same length. So, what shape has 2 sets of parallel sides and 4 congruent sides? You need to remember, we do have right angles. So what shape could that possibly be? Oh my goodness, you're right. B-E-A-R. B-E-A-R is a square. It's a square, ladies and gentlemen. Woohoo! Because we have perpendicular sides and we have 4 congruent sides. Boom, done. BEAR is a square. So you're going to have to keep in mind all of the lovely characteristics of quadrilaterals. And we are done. Next up, in the next slide, oh my.